Okay, so 3,500 kilometers. This is more or less the total length of all the national roads and highways that we have in Poland. But what is interesting here is not how big this infrastructure is, but how do we maintain it and how do we extend all these roads, which I experienced this morning, by the way. So how do we do that? For example, in 2017, we've built 350 kilometers of new highways. In the same time, people were driving it and well, basically using what we already have. And well, we were fixing these roads, closing some lanes, just working with existing infrastructure. So this is the example of the process where we built on top of something that we already had, which means that it's a incremental process where we maintain existing infrastructure. To get a little bit better intuition on what incrementality is all about, let's try to find a contradiction to incremental process. So if you type data processing incremental versus in your favorite search engine, you're gonna have some nice suggestions over there. So incremental versus full, or incremental versus absolute. Batch or bulk, we would say in the software world. So this is indeed what's opposite to incremental. The bulk process, when you start with hitting the delete button, just getting rid of everything you had so far, and starting your process from the scratch. Now, having the previous example in your mind and describing this like, okay, just let's get rid of everything that we've processed so far, may sound a little bit stupid. Why would I get rid of that, right? I had my beautiful results. Why not build on top of that? However, in some cases, it makes perfect sense to apply such a process. So let's have a look on such an example. So this is the railway station in Łódź, where I live. It's called Łódź Fabryczna, and believe it or not, but these two pictures show the same place, just five-year difference. So this station was rebuilt to something completely new, and actually doesn't look like same thing. And the whole process took 5 years. Which means, because of the fact that it was a batch process, that no one could use the station for those 5 years. Try to disable your service for 5 years for next release. But this is how it works, and well, probably you could apply incremental process over here. I guess it would be possible. However, it would be also cost ineffective. It would take more time and resources to convert first picture into second in the incremental way. So it does make perfect sense to do this in a batch way. Now, interesting thing. If you would be choosing the process for those two examples, it sounds pretty obvious, right? Even though we are not experts in this field, it's quite natural to use incremental process for maintaining roads and batch process where you just raise everything to the ground to start over new building. Is it equally intuitive and obvious to choose the right process for your data processing in the IT world? Is it? Well, let's now try to think about the data processing example. So imagine you have some input data that you store in a database. You're getting it in a queue or whatever. So the data is keeps on changing. There are new data coming in. You need to process it somehow. So there's a logic, maybe some framework that is used to implement your business logic. And in the end, you have your result that you need to ship to your customer. You provide it over some API, or maybe this is just yet another step in a longer process. And let's assume that you want to ship this data periodically. So on one hand, you have this data that is being changed, new data incoming, and on the other hand, you want to provide your results of your processing periodically in a time. Now, what happens with the cost of the process? In the incremental way, the cost will stay the same no matter how often you want to provide the results, because the cost of this process depends actually on the amount of changes that are coming to the source data. So the delivery frequency doesn't matter. On the other hand, in the batch process, every time you deliver results, you need to restart your process. You delete results and you reprocess everything again. So this is the relation between these two. And if you plot this relation like here, it's pretty obvious which process you should choose for your processing. So in other words, well, this talk is focused on incremental processing. So if your business cases are more to the left side of this drawing, I'm gonna probably waste half an hour of your time. Sorry, or maybe not. There might be something missing here still, right? The cost. Oh, now it's missing for sure. Okay, give me a second. Yeah, sleeping while presenting. That's awesome. So there is something missing over here. The total cost of your processing is not just running your computation, right? It's not just the hardware. It's not just data transfer. It's also development, testing, and so on. This is the complete cost of your process. So, why do we actually talk that much about the cost over here? Why would that be interesting? Well, in the end, you need to choose somehow the right processing for your application, right? And if you've ever tried to search proper definition of software architecture, most likely you found this sentence. So, all architecture is design, but not all design is architecture. Architecture represents the significant design decisions that shape a system where significant is measured by cost of change. So, you could make it a little bit simpler, saying that architecture is all about the cost. There's design in it also, but mainly you should think about cost, I guess. So there are a couple of different decisions that you can make, and they drastically influence the cost. So first of all, having those first examples that I gave you, you could purely see that the cost difference is tremendous for those two processes. Now, one of the ideas that you could apply is called Lambda architecture. The idea is stupid simple, I would say. It's just saying, okay, let's combine both ideas. So let's put batch processing next to the incremental one. They call it typically the speed layer and the batch layer, and use both. But what does it mean? Because of the fact that you have incremental processing it means that you're gonna be able to ship your data very often, right? Just like in the first example when you were maintaining existing infrastructure. This is very very similar. So why would that be? There would be still needed the batch layer. So let's go through all the idea and see how it works. So on the beginning, you have new data coming. That could be your queue, Kafka, I don't know, stream, whatever, or maybe just a database with events stored over there. What do you do with this data? You clone it. You ship this data to both layers in the same way. And what happens with this data? In a speed layer, so the incremental part, you process everything as it goes to your system. You process it and you store your computations into some, well, database, some storage, whatever. This means that this data is ready to be shipped to the customer, and he's able to see the results. However, this architect. Damn, I was so close. Of course, wrong password. Anyone knows my password? Just a password. No. Okay. Here we go again. So, in the same time, the data is being stored in a batch layer, and it's just waiting for an opportunity to be processed. Why we would need that? Well, when we implement that, it's just some place where the code is. And where the code is, there are also those little furry creatures called bugs, which we have to solve from time to time. Sometimes there are also new requirements coming from the customers, so we need to implement them and ship new types of data. But this means that from time to time, you need to reprocess big bulk of your data very quickly because you need to fix this bloody bug or just introduce new feature quickly. And you don't want your customer waiting for that for a long period. So this is where the batch layer kicks in. So if there is the new software release or some bug fix, you can start your batch processing, you deliver the batch view to the customer, and in the same time, all the new data is being processed by the speed layer, which means that you can combine these two results to get the fresh result for your customer. Sounds great, doesn't it? I'm gonna touch it. Clever. So there's just one problem related to that. You're gonna produce lots of code. That's the biggest issue with this architecture. So what does it mean? It means again that there is a cost, and you're gonna pay this cost every time you want to introduce any changes in your system. Because if there is a new requirement, again you need to implement that with both paths. If you want to test that, you want to test that in both paths. And moreover, you need to verify results from these two paths, whether they are consistent or not. It's very easy to get, different results from both versions. So what you can do is again quite simple. Just get rid of the batch layer. So what does it mean? It means that you're gonna lose part of your functionality. You're gonna have to reprocess in the batch mode using incremental speed layer, which means that it won't be as fast. So I'm going to give you some examples of the incremental processing that we have at TomTom. So if you paid attention to what I've shown you so far, is that the arrows actually changed. So typically when they present Lambda or Kappa architecture, and by the way, Kappa architecture is basically event sourcing. It's just the same idea. So when it's being presented, typically they show arrows like this, so they represent the data flow, which I don't really like. And I have a reason for this. So coming back to the definition of architecture, when you think about the costs, you should also represent the costs whenever you try to explain some idea. And the problem is that if you just represent the data flow, you don't really tell what are the responsibilities of different components in your system, because you don't know which component is responsible for starting the conversation and so on, which might be really, really important. So what we found in our example was that to get consistent results, you need to get this responsibility in the processing part, which means that you should get a component that is actively pulling the data from your source, and this is the only place that is able to figure out that, okay, I have processed this part, I'm able to save this kind of results in my target data and ship it to the customer. So this is the reason why now I'm showing you the usage arrows. The next thing that you can see here is that I've shown you the implementation that we used for source and for results, which is PostgreSDB. So if you've listened to the Pierluigi's talk, you know already something about the data that we process at TomTom. But it's pretty clear that we have lots of location-based data, which is quite typically accessed via spatial calls. And what's interesting is that there are not too many technologies that serves proper access to spatial data effectively. So this is the reason why we've chosen Postgres. But actually, you can use very successfully relational database to store set of new events incoming and read them, just like it would be a stream or Kafka or whatever. In the middle, you can see those processing services. So this is basically the place which is responsible for reading the data and putting it to the results. Now, interesting part is the third point over here. So squashing the data. What do I mean by that? This is the place where we're trying to trick a little bit the disadvantages of incremental processing and Kappa architecture. So knowing that there are lots of data incoming to our source data set, we can assume or just check or experiment with that that lots of this data is not really new. These are just changes of the data that we already had. This means that periodically we can just squash everything together and save data again to the source database to use smaller footprint for our reprocessing. So batch processing on top of incremental architecture. So how do we do that? We've noticed that the processing part can be split into couple of elements. So why this is important? So this is a little bit like coming back to the Lambda version, where you had two separate frameworks for batch and incremental. However, what we've noticed is that the complexity and the cost that you have to pay for re-implementing tests and functionalities and so on comes not from the source, not from reading the data, not for writing and providing it to your processing, but actually from the business logic that you need to implement to process the data. I'll give you an example. So having that said, that we have location-based data. So think about the new data, the X part. as a map. So definition of reality. This is the place where we store all the shape points describing our roads, attributes describing speed limits, road names, and so on. And we need to provide this data to the applications. So application, think of it like the display application or routing or search, is not very keen on reading exact description of the real world. You need some abstraction on top of it, right, to make it usable. And sometimes you need to change the format. You need to store it in some specific database. So this is more or less what we did so far. And know that for different applications, you're gonna create different results. So there are gonna be lots of those F parts transforming the data, but it's not exploding in the cost that we'd have to pay in case of introducing some changes, because the batch and the incremental part is done in a generic way for all these functions. That's basically the idea over here. Obviously, the performance that you're gonna get from this kind of solution is not exactly the same that you're gonna get from proper batch layer. And mainly the reason is that because you want to mainly use that for speed transformations, probably you won't be able to use off-the-shelf tools like you could do for batch processing. So Hadoop probably won't help you this. There are some tools, but it's, from my experience, more or less very entry-level help that you can get from these tools. So and they will be mostly tuned for stream processing. So I'm talking about things like Kinesis, Apache Flink, this kind of stuff. The last thing that we've learned is typical for incremental processing only. So the incremental process will be always a little bit different from batch one. So even if you think about something really simple, like calculating average out of a set of integer numbers, this will be just different in both cases. So in batch world, you're gonna just sum up all the integers that you had, and you divide that by the count, right? As simple as that. If you want to do it in the incremental way, you need to save some specific data for this processing. So you need to at least get the count that is being saved. You need to get intermediate sums and so on. So it's just a little bit different approach for processing, and your algorithm will be different. Now think about more complicated cases. So having the example that I gave you before, which is transforming map into some different view of this data, like preparing this data for being routable or searchable. It means that there might be a different relation than one-to-one from your X to Y, right? So if you want to reprocess changes that happened to your source data, you need to be able to very quickly notice which data is connected or were connected by the old processing. So actually, if you try to search for any white papers or theoretical explanations on how to do incremental processing, this is one of the very first things that you're gonna notice. You need to save the traceback information. They call it differently sometimes, but this is basically the idea. And we tried to be smart, so we read all these white papers. We noticed that we need to save that, and we said, okay, this is easy. We're gonna put some NoSQL technology here because it's just a relation from one set to another. Very simple data, no relations. Gonna be easy. We use DynamoDB that. We took some data from production for testing. We were so happy seeing that it's developed so quickly because it's managed service. It's so cool. And then we noticed it was an absolute failure. Really big disappointment, because what we've learned with this tests is that because of the fact that the process that you need to implement here has to be concurrent, you're going to be processing same data concurrently for different versions of these objects. What does it mean? It means that when you have this relation from 1 to A, from 2 to A, from 5 to A, they might be appearing in a time. So it might be just represented as a history of the X, which means that you're gonna need more data for finding these relations than just X to than just 1 to A to B to A. You're gonna need to store some versioning here, or data. I knew it. Just to figure out which version should be processed first, and what is the order. So to do that, you're gonna need more indexes than just X store. And what you're gonna find then is that, yeah, you can perfectly do that with DynamoDB because they have those secondary indexes. But then what happens is that you're gonna end up with inconsistent views in your serving layer because you process data concurrently, and what is property of secondary index in Dynamo is that they're just not consistent. So the only idea that would work here is to store the data that helps you to track these connections somewhere close to the serving layer results, just to get consistent proper views over here. The last thing I want to show, I want to tell you about is the data that you store in the serving layer, because sometimes the cost of introducing this kind of incremental processing is not only related to the processing itself, but also with providing this data to the application, right? These guys need to read the data too. So you need to reflect somehow this incremental process in your data. You need to model it, you need to make it available over your API in a way of changes or events or modifications that happens to your data. So this is more or less it. We use this process quite happily at TomTom. We do it with a couple of different types of data. So one is the search indexing, which I already told you about. We also do that for display informations. So imagine this data in a way that you have raw data in X, and you need to transform it in a way that is could be nicely displayed in Y, just for the sake of having it available in your application. So why is it important? It's the incremental process is just helping us to deliver data quickly and quite efficiently to the customer, to the applications, just to make sure that data that you rely while driving or just watching the map is fresh and describing the reality correctly. So I'm gonna end with this. Thank you very much. Any questions? Thoughts? Remarks? Yes? Mm-hmm. Yeah, so this is simplified. Obviously, you don't we don't expose direct access to the database. So the serving layer that we have right we had right here is kind of a database that is exposed over an API. So as I said, what you need to expose to the application is an API that will allow you to tell that, okay, I'm at this point of the history, I need to process more fresh data, and this is how I traverse from this point in history to the most recent data. Okay, thank you.